Welcome to this month Computer Graphics Lab Talk, this time done by 4 speakers, by Olga, Jan, Jaroslav, and Petr. They're all working for a company in Prague called GoodAI, doing research and I guess also development on AI. We met at a trade fair at Friedrichshafen because part of the team is working also on drones. And I think we will see a little bit about this also in the presentation today. So they're going to share the presentation today, and the title of the presentation is The Power of Collectives Exploring LLM. So these are large language models driven agents at GoodAI. So floor is yours.
Thank you very much. Welcome everyone. And we're very happy that you are able to join us and listen to the things that we are working on. So as the title says, the power of collectives, it's something that we have been interested in for a long time. We have done many different research or much research in collective learning, collective intelligence. And essentially today we will show you kind of 2 aspects of this work, one related to a game that we're developing, and another one related to drones. And Olga, and Petr will talk about the drones, and I'll talk about the game. So yeah, my name is Feyereisl. I'm a research scientist at GoodAI, and yes, this is what we are working on. So essentially, there are 2 kind of primary areas. One of them is the AI game, and most of the talk, or the first part of the talk, will be about essentially this game. And why it's interesting is because all of the NPCs within the game are essentially fully fledged agents that act in the game world and that are driven by large language models. But in addition to this work, we also have another group that looks at autonomous general agents, and they also exploit the benefit of collectives by essentially being a collective or a group of agents that are also driven by language models, and that exist in order to be able to learn from experience from users, adapt to them, and be able to essentially solve many different tasks via kind of code generation. So I'll not talk about that much here, but a lot of the methods that we use in the AI game and in these autonomous general agents, they kind of share similarities, technologies, and so on. And kind of here in the top right corner, there's like a small video of some of the work that we did in the past regarding collectives. It's something that we call Mimetic Badger, and essentially it's this huge collective of thousands of neural networks that were essentially learning online in order to exchange memes or information amongst each other in order to adapt to various conditions, various environments. And it's something that kind of looks cool and what we worked on in the past. So just to kind of give you an idea. So as I mentioned, in the AI game, all of the NPCs are essentially fully fledged agents. Here at the bottom, you can see the player. There are 2 NPCs, and what happens here is that the player can essentially talk to the NPCs in natural language, because in the background is a large language model. And here I just want to show that essentially the player says to the chef that he saw this guy who is her husband, that he was kissing somebody else. And essentially what you can see here is that the language model generates a thought based on the conversation that we just had. And it says, Sean Thomas betrayed me, I must confront him and find out why he did this. So this is already the language model at work for reasoning. And this essentially starts this chain of events. Again, everything is driven by a language model, nothing is prescripted. And now the character initiated a conversation with the prisoner, with the partner on the left. And of course, she's upset, he's trying to defend himself. And they essentially exchange a number of sentences, and eventually it results in this character essentially attacking the partner, and while he's running away, he's still reasoning that he needs to defuse the situation. And this is just one example, but of course, given the fact that language models are stochastic, every single time you play the same scenario, you might end up in a totally different result. For example, this lady not believing you as a player and actually going after you. So as an overview, essentially it's the game is has NPCs who are embodied agents. They're able to observe the world, act on their own based on observations. All of the behaviors are driven by large language models. So it's not just talking to the NPCs, but literally all of their actions and decisions are agential in that sense. We put a lot of effort into creating a long-term memory because language models, they're stateless, they don't have any memory. So we have a separate module which essentially stores everything that happens in the game so that the NPCs can learn from conversations, but also from their actions in order to learn behaviors and skills that would be useful in the future. And all of the NPCs, they have some goals, some high-level goals, and some kind of local short-term goals, and they try to achieve them. And they're able to reason, interact with each other, have different emotions. And also one thing that we're still working on is this AI director, which can essentially steer this collective as a whole into certain directions that are interesting for the players. So essentially it's a way of injecting more interesting situations and scenarios into the world. So it's a sandbox, open-ended kind of simulation type of game where there's a lot of emergent complexity. So let's show some more examples. In this case, this NPC, he's actually Zeus, so he has some personal description, some biography, and that influences his decision making. But right now, he is actually given a goal, and the goal in this case, I think, is to bring a bunch of objects. So he actually decides to talk to me as the player, and I can instruct him to essentially what I'm interested in bringing. So you can see we have an interaction with the agent, and based on this, the agent reasons, I need to collect 3 items that Archie needs. I should start by looking for an apple, axe, and a stone. And when the character is actually not moving, he's thinking. And based on this kind of reasoning, he creates a plan, which is to go and pick up the apple, pick up the axe, and pick up the stone, and then bring it back to me. So again, from if you see this in a standard game, a lot of those things are pre-programmed, but here, everything that you see is essentially determined and reasoned about and kind of set in motion via a large language model. So you can see he successfully completed the task. Here's another similar example, but in this case, he needs to burn down all fences. So he says it's a piece of cake. So in this case, he needs to figure out that actually there's a torch. The torch can ignite wooden objects. He can actually explore the world, and when he explores, he learns more and more about individual objects. So he found out that there are wooden fences that he needs to burn. Then he goes and figures out that a torch might be a suitable tool for that. Then he goes back to the fence. In this case, he picks up another torch, of course, because language models are stochastic, so the plans are not always optimal. And then he's able to go and iteratively burn the fences one by one. So you can see there's this multi-stage way of actually reasoning about the task and then progressively working towards achieving that goal. So another example, in this case, we specifically instruct the agent via communication with the player that we want the medicine. And why this is interesting is because it's unreachable. So it's actually enclosed in this within this fenced area. And when this happens, there's this feedback that's really important. I can talk about it a little bit more later. You can see it here. He reasons that the path is blocked by a wooden fence and that he needs to get around it. So simply by essentially providing observations and the goal and sufficient feedback, he can reason about this successfully. So you can see he doesn't see any holes in the fence, so he decides what to do. And on the top right corner, you can a little bit see the current task and the actions that actually the plan is generating. So you can see that he was able to reason about the fact that an axe might be a suitable tool, then use the axe on the wooden fence. In this way, yeah, he also says one should be careful. And he's able to pick up the medicine and bring it to action. So in this sense, it's actually quite a nice example of fairly strong reasoning in a situation where a task is unachievable, and this loop that I'll show you in a bit is able to resolve it. So, and this is a situation where we have something of a collective. So those are 4 agents, and their task is to collect apples, live or die. And each of the NPCs, they have a slightly different biography. So you will be able to see that this character is more violent, this one is more timid, this one is a regular person, and this one is always focused on the player. So he's talking to me, but this guy is saying, give me all the apples you have, and I don't have time to waste. So he's more aggressive. This agent replies in a more normal way. Don't lie to me. And essentially, as you will see, that based on the conversation, he doesn't believe him, and he actually goes, picks up an axe and starts going after him because he believes that he has apples that ultimately is the goal of his world, of the agent's world right now. And so right now we don't have reactivity, so those characters actually should react when we disable it, just to see that the language models are doing the reasoning well. And he not only killed him, but actually finished him with a stone, which is a little bit, improper, but still interesting to see. And then he goes and picks up the apple. And here's one last video. So here we have even more NPCs, and their goal is to essentially explore the place and have fun. And you can see that a lot of them are reasoning. They have some conversations. And if I kind of skip forward, you can see that those two have a conversation that they want to play something. The warden, he has a personality that is quite nasty. The prisoners are useless. I need to find someone weaker than me to bully and assert my dominance over. And those two guys, they're just saying that first they want to play basketball, but they're not interested in it. Maybe they can play, knife throwing and so on. So in this case, they don't do that many actions, but they have a lot of social interactions that can be interesting to explore. So here is kind of an overview of the system. So there's this large language model, and each of the NPCs, they have their goals, their memories, and we have designers who actually define the personalities of the agents. We provide observations and recent events as kind of input. So those are the green boxes here. And then the language model is fed all of this information with specially crafted prompts that generate essentially instructions that are parsable by the game engine that are then executed. And as I mentioned many times, none of this is scripted, and we only use some basic pathfinding in the game engine, but that's just execution. And this is something related to something called plan and execute. And that's when you actually have goals that are not currently executable in the world, but you need to decompose them. So we have this framework that allows us to take the goal, decompose it into simpler goals. Once those simpler goals are at a level where they can be executed by atomic actions in the world, we can there stop and actually pass this goal or this task to the lower levels. The lower levels then create a plan that actually map directly to the API of the engine that is able to execute this. And this is kind of a universal framework that could be used for many different things, including drones, including robots, and a lot of this work was actually inspired by robotics in the first place. And a very important thing is feedback. And here's a more general overview of the system. So you can see here is the agent, excuse me, with some kind of region of interest from which it gets observations, such as items in the world, in the inventory, and the ones that are held. They go into some world model or data store that actually is able to track the world information. Then we have the character descriptions together with some global goal and the events that the game generates, which includes feedback. So there are 3 different data stores with potentially some high-level reasoning that the language model does in order to be able to abstract and summarize what happens at the level that is more useful for subsequent decision making. And all this information then goes into a reasoner. So what we do there, we essentially retrieve in a smart way the items or the observations from the world together with the events that happened in the past that could be relevant for the task that the agent is doing now. And that generates a thought, an emotion, and an action plan. And the thought is the reasoning bubbles that you saw before, but that itself actually helps the decision making because the language models, if you give them space to actually reason, they make much better plans, much better actions. And emotion is something that can be converted into visual animation. And the action plan is the actual task that is then passed on to the action planner, which is the lower level kind of plan generator. And you can see here, it's generated as code because language models are very strong in generating code, where we essentially have defined functionalities in the game that somehow can be called, and the language model generates like a sequence of actions based on this action plan. And this goes into a parser that is able to then actually queue and execute actions and animations that actually are visible in the game. And this really important thing is this feedback, because of the stochasticity and the fact that the plans might not necessarily be good enough, or because there are some obstacles. If we have this feedback, obviously the language model can reason and actually generate better and better plans. So here are some examples of some prompts. In this case, it's the reasoning prompt. So I will not go into detail, but essentially language models allow you to give them instructions that somehow restrict the type of information or the generation or text generation that they do. And based on this, we essentially provide the observations, the events that happen in the game, which you can see a little bit here. And it's of course a little bit simplified. And when it says your turn, then the language model generates those three outputs, which are then passed in the system to the next stage. And here's another example of this kind of high-level goal decomposition. And again, it's a way of essentially describing the world of the game itself, how it should kind of reason about the goal and decompose it. And once it makes some decisions about how to decompose the goal and whether to actually stop, there are some questions that language model answers, and based on which we decide whether we should continue decomposing, whether we should kind of replan, or if we're actually finished with the goal that we wanted to achieve. And a little bit about long-term memory. So as I mentioned, it's just this data store that allows us to record more or less everything that happens in the game. And you might have heard about different kind of vector databases. And what we do there is we essentially somehow specially weight the records based on recency and a bunch of other measures that make it much more similar to the way that the human memory works. And it's really important to have this because for the experience, if you actually talk to the NPCs and the player actually has said something in the past, you don't want this to kind of disappear. And because we have it there, this long-term memory, we're able to store things that the agents have learned over time. And if we're able to retrieve this, we don't have to let the language model need to discover things that it has already solved in the past. So it approaches kind of continual learners. And here's just an example, quick example of conversation, where essentially the player talks with an NPC about the particular thing that they did in the morning. And after this conversation, some time has passed of gameplay. And essentially without long-term memory, obviously, the NPC wouldn't remember. So it would be very unnatural. But if you actually enable this long-term memory, then it's persistent, right? So you can see that the NPC will actually remember exactly what the player told them in the morning. And yeah, there's a number of challenges. So language models are really interesting because they are able to do a lot of this kind of reasoning and decision-making, but they are unreliable in terms of robustness. So they are not always easily controllable in order to generate reproducible plans, reproducible actions. And sometimes if you change the prompt a little bit, it can result in potentially large or big changes in the output. Of course, with GPT-4, the best model from OpenAI, this happens less, but because we're using GPT 3.5 simply because of the cost, then this is something that we have to worry about. Also hallucinations. So a lot of times the agents can hallucinate things that don't exist in the world. So grounding the agents sufficiently is really important so that their plans and the decision-making and their actions are actually kind of synchronized with the world. And RLHR, that's reinforcement learning from human feedback, and it's the way that actually you can control models to make them more suitable for interacting with the language model, and also for minimizing harm. So talking about illegal things and so on, it's sometimes too strong. And for example, in the game, we want to be able to generate interesting situation and interesting characters, so that can be a bit of a problem. And of course, the context window, so there's a limited size of how much data we can provide with the language model. But this is less and less of a problem because this keeps on increasing at a very quick pace. And right now, everything is language-based, so we do not have any modality like vision. If we had access to vision modality, it would be much easier to reason about the spatial structures and so on, even though with language, if we use coordinates, the language models are able to reason spatially much better than one would have expected. And yeah, so I will just briefly mention some related work. I'll just skim through it and I'll hand over the word to Olga. But just for anybody interested, there are a number of works that kind of do something related. Generative agents essentially simulate this kind of entire community in somewhat similar way, but of course it's less interactive, but it's still interesting kind of to see and read, and they have some nice approaches towards abstracting kind of reasoning over what happens to the little characters in the simulation, and how to store information and so on. And more recently, there started to appear different papers that actually do have agent in something like Minecraft, where they have a special curriculum in order to actually learn progressively more and more complex skills that again are used as or generate programs and then store somewhere and retrieved for later. And you can see that essentially this method is much better than any other existing method for this type of decision-making task. This is another paper which is very similar, essentially learning this skill tree of skills in Minecraft. And some of you might have noticed this whole AutoGPT storm on Twitter, which again shares some similarities in the sense that you give it a task, and it does some kind of decomposition, have potentially multiple different agents that are then progressively kind of working away on the subtask in order to achieve a bigger goal. And a little bit more relevant maybe for you guys, it's ChatGPT for robotics. Again, it's a very similar type of architecture or way of dealing with language models, which is that you essentially somehow describe and define ways of calling function within your API, whether it's for a drone or for some other system. and how to essentially set it up so that when you give a task, it can successfully call the correct functions. And actually last night, OpenAI released a new version of their models that actually includes this as part of their models, so that the output that it generates is much more valid and more likely to be a valid JSON output that can actually fill in the parameters for the functions that you define. So it's definitely something that would be could be interesting for anybody who wants to link language models with any kind of external physical system. And this is just a really nice paper of storing information and kind of rewriting that's useful for the long-term memory, so that in the future, when a user actually interacts with the language model and he or she has some preferences, the language model is able to actually retrieve the things that happened in the past in a way that will kind of override the information that was naturally trained with the foundation model. So it's, again, something interesting to know. And with that, I will hand over the word to Olga.
Right. Thank you, Jan. I think I will share my own screen, right? Okay. Just give me a second. All right. So, can you see my screen? Can you hear me well? Okay, so we have maybe something under 20 minutes for the drones part. So I will just give a quick introduction in general what the project is about, and then I'll pass the word to my colleagues, to Jaroslav and Petr, for a more technical part. So we're actually a very small team within GoodAI. So GoodAI in total has about 30 people, and for the drones, it's just the three of us, me, Jaroslav, and Petr. All right, so okay, let me just quickly figure out. All right, so our vision has been, we asked ourselves a question: what if we could augment ourselves with these collectives of small intelligent agents, but not just in, in the computer on the intelligence level, but also in the physical world. And Jaroslav and Petr have always been fans of drones, so we sort of started experimenting with that area. And currently, basically, we're looking at the whole problem from two perspectives. First one is managing the complexity of using the drones. So currently, you have to pilot them manually. There's different software you can use to plan the missions, etc. So we found that in the use cases that we investigated, that was really a big a kind of hurdle for a lot of people to start using the drones for different purposes. So we started working on our own ground control station with intuitive user interface to enable people to basically do the tasks with drones much easier. And then the second pillar is we're interested in this collectives of collaborative drones, and of this concept of how they can work together to create versatile and powerful tools based on the tasks you give them, and different sensors so that we can equip them with them, how they can be combined. So basically, through our ground control station, our user interface, our goal is to give the user or the pilot, the user of the drones, the ability to specify a high-level mission for the group of drones, and then everything else will be taken care of by our software. So you wouldn't have to do a lot of manual steps. This is where potentially we could introduce the language models, and my colleague will talk about the ideas there after my part. So, to start with, I just wanted to show one of our demos where it basically shows the current capabilities. It's a couple of months back, but more or less it shows the capabilities of our system and some basic scenarios at this stage. So you will see the screen grab from one of the laptops. So it's nothing fancy, but it explains nicely what's the capability. So you will see a scenario for security where we have two drones set up, and the first drone is set to fly a predefined preset patrolling mission. So you see it taking off. The second drone is still on the ground. And basically you will see this drone following the trajectory that has been preset. And currently the task for the drone is to follow that trajectory and identify any anomalies. So the anomalies in these cases would be it's looking for people and cars, and obviously sometimes it finds out a false positive, which the user can easily reject. But it also found a car successfully. And then after a short while, it will be looking for and finding a person. So you will be able to see quite soon in the bottom left corner. I think the video is too small, but perhaps you will be able to see also a bounding box around Jaroslav actually there. You can also see that the drone and the software has already placed the picture of a detected person on the map. And basically upon that, the user decides to use a feature that we call a panic button. It's any kind of GPS located trigger that we can use to do some action. So in this case, the action would be to deploy the second drone, which automatically receives the coordinates of this found person and goes to that location. And actually, it will kind of the task will be to stick to that person and hover over it and follow it. So you can imagine it for different scenarios like security, person detection, and different security situations where you need to find someone who shouldn't be there, or for search and rescue scenarios, etc. So you can see actually that second drone is now following this person. You can see the bounding box around him. And here you can see the drone actually following Jaroslav here, running around the corner, while the first drone has finished its patrolling mission. You can see it's on the ground and still looking around. So after a short while, our perpetrator will jump into a vehicle and try to escape. You can still see that the drone sometimes detects false positives that need to be manually rejected. And basically, the drone is now going to look on this car, on the vehicle, and follow it up to the point till the user will decide that it's not anymore needed and that the drone can stop the mission and return to its original position for landing. So, all right, so basically what we're trying to do, we've been working on it since late last year, so it's not too long, and we're trying to test our prototypes as fast as possible. So we're already approaching first clients, and what we actually are offering them currently is some sort of all-in-one solution. We want to see how they use it, we want to see how useful is what we're building and iterate together with them. So we're giving them the ground control station, we're offering them integration into their systems. So for example, drone can work together with some kind of early warning system. Let's say in a security scenario, if you have a motion sensor that gets triggered, then the drone could be automatically sent to the location, etc. Also, basically, the idea that we're giving to the people is that you should be able to control your drones easily through this user interface. You should be able to control different drones in different locations. And basically, we try to make it as easy as possible for them. So we kind of try to manage the complexity for them and equip the software with the AI features for this anomaly detection, person detection, object detection, whatever it may be. So person and car is one example, but for example, tracking some animals or wildlife can be another example. And the use cases revolve around a few areas. Mostly it's monitoring different high crime areas in the national parks in South Africa, which I'll also talk a little bit about more later, because we have a little bit of a connection to South Africa and know people working in security there. And their safety and security and crime prevention is really a massive issue or massive challenge. And it's really very motivating to see that the drones can actually make a difference. So that's how we kind of ended up in this area of use cases. So it's crime response, tracking poachers, tracking different perpetrators, integration with early warning systems, as I mentioned, and different as we call it, panic button scenarios, which can be, for example, someone has a literal panic button in their pocket and then can press the panic button, the drone can arrive at the location, or it can be any kind of location that we identify or connect to a sensor on a map, and the drone can be sent to that location. So our friends from this organization called Community Crime Prevention in Ph.D, which is a town near Cape Town, they have been doing their crime prevention work for over 10 years, and they've really managed to decrease the rate of crime like orders of magnitude. So it's becoming very safe. However, one of the use cases is, for example, here you can see a town called Camps Bay, and here maybe you can see this faint red line, which sort of like shows this national park area where there are different jeep tracks and hiking trails. So what actually happens is, because this is a very popular touristy area, and it's actually near to Cape Town Central and main landmarks, a lot of tourists go there for hikes, and it's a crime hotspot, so they get mugged on the trails. So that's one thing that the Community Crime Prevention Organization wanted to tackle, is to have patrols over these areas and basically detect if there is any kind of person presence, and they can always check if it looks suspicious or not. And then if you look at the border between the town and this green area, this is where the mugging, the house invasions happen quite often, house robberies. So basically during the night, they would be interested in patrolling these parts and seeing if there's any person detected that obviously they probably shouldn't be there. Maybe they're up to something not really good. So this is one example. And as you can see, this is a really stunning area. A lot of people go and hike there. This is actually our setup, how we were conducting experiments right there with local national park authorities. Yeah, so unfortunately, like this is crime-ridden, relatively crime-ridden area, and it would be great to improve it. And then another use case, I mentioned this panic button functionality that we have. The same organization, Community Crime Prevention, who actually come from this town of South Bay, for the residents and adjacent towns, they created this wonderful app, which basically allows anyone who has the app to place any kind of report. It could be a crime report, it could be a medical alert, it could be search and rescue, it could be a municipal kind of issue. For example, your water doesn't run. And the control room of the Community Crime Prevention receives these alerts and immediately responds and coordinates the response. So for example, they get a medical alert, somebody's hurt, they usually call the person, or they check on the map where the alert is happening, and they can coordinate. For example, they can send the medics, they contact the medics and they send them, or they can go themselves and respond to some alerts. For example, catching a snake, which is in your garden. Or what they would really love is to actually be able to deploy the drone and get the drone first to the location, so they can get a better picture, better assessment of what kind of response is needed. So that's another use case we're looking at. And actually, while there in South Africa, during our visit early this year, we were assisting with search and rescue in this area. Unfortunately, it was rather search for clues or potentially the body of a missing person, because it's been already several weeks since the disappearance, and there was barely no chance of finding the person alive. So you can see actually the bush is very, very thick. So something like the work you do would be very, very, very useful in search and rescue scenario like that. And unfortunately, we didn't find anything. And the last example I want to talk about is, for example, cattle theft, which again in South Africa quite common. So somebody comes in and grabs a sheep and walks away, usually at night. And we had some conversations with a group of farmers where we actually made our demos on the farms, and they built an amazing app for tracking the sheep, which you can see the herd is usually quite large. So they implant a few GPS trackers just into a few of the sheep. And on the app, they can see basically the raw pattern of the sheep herd movement. And there's certain regularity in it, and they know usually how the sheep behave. But once the pattern becomes chaotic, it means that the sheep is getting excited and disturbed by something, either a poacher or a wild animal or anything. And that basically sends an alert. So something is happening. And what happens is then the security response team jumps in the vehicle and drives to the location on the farm, but it can take some time. So obviously sending a drone there, connecting it with this sheep tracking app would be extremely handy. Yeah, so I guess this gives you a little bit of an idea of what we're doing, why we're doing it, what kind of use cases inspire us. And without further ado, I will pass the word to one of my colleagues, I guess to Yada, right?
Yes.
And over to you.
Okay. Thank you. Can you see the slides? Yeah.
Yes.
Good.
Yes.
I have just a question. How much time do we have?
It's like 20 more minutes.
20 more minutes. Okay, great. Thanks. Okay, so my name is Jarda, and together with my colleague Petr, we are working on the technical side of the project of the drones. Yeah, I would like to tell you just like very briefly how our ground station application looks like, and then like basically provide some ideas where we would like to use AI in the context of drones. So right now we like basically some time ago we started thinking about how to make drones like more useful and more usable by more companies. So we are thinking like what is missing, and we came to the conclusion that the main thing which is missing here is some ground control station, which will be very easy to use, and basically people will not need some special training for using it. So we started developing a ground control station software, and it has basically two main goals. One of the goals is to be usable right now, so that we can provide it to customers, and the other use case is to be useful for us to be able to serve as some playground for testing different AI models and different scenarios with drones. So this is basically how our software and hardware setup looks like right now. So here you can see the ground control station schematics. So it has a web-based front end, so that it's easy to open on any operating system. Then it has a backend which is written in Python, and it is communicating through some standardized Maverick interface, which is used by custom drones community. So you can see that we can easily connect to this interface with some Ardu Pilot drones, which are typically Ardu Pilot is a software stack used by open source or custom drones. We can also connect it in the same way to the simulator, and we wrote our applications which are running on the RCs of DJI Mavics, so that these Mavics then pretends to be Ardu Pilot drones as well. So in this way we can seamlessly control like very big range of drones. Currently we are doing most of our experiments with these Mavics. So this is how our ground station looks like, and the backend it's written in Python. Like one of the reasons for this was that you can easily run AI models which are written in PyTorch. So right now as you were able to see, we are using some detectors and which are implemented by neural networks and running on GPU. So now as you know what is the current state of our application, like we are now at this moment we are polishing it, and so that it's more reliable and easier to use, and we are thinking about like how to use it for experiments with AI, and currently we have like few ideas where some AI models, and particularly large language models could be useful in the context of these drones. So I would like to show you just like a few examples what we think could be interesting to do and potentially useful, and it can be just like subject to further discussion. Like one of the obvious things, we would like to try experiments step by step. So maybe you don't want to change the whole application so that it's controlled solely by large language models, so that you would have to discuss what you want to do with drones in the format of language. But we would like to do some iterative approach where basically some things are easier to control on a computer using mouse and keyboard, but some things are easier to explain by language. So if you want to think about controlling the drones, like we would like to find some good compromise, like use language models where is it easier than UI, use classical UI where it's easier to use classical UI. So this is just some mock-up, like here you have a map, and you have also some interface where you can talk to the application. We think that one of the most interesting opportunities here is to use language models to as an interface with ground station, and basically one of the main benefits could be that the software can somehow proactively explain to you what is it capable of and what is it not capable of. So if you want to configure some missions in drones, you have to know a lot of details, and the UI is usually very clumsy. You have to know that you can't fly over people, over buildings, over some specific areas, and also you have to be aware of like limitations of I don't know, signal and all these things. So basically, it takes some experience to be able to do these things. So one of the benefits would be that you could communicate with natural language with the application, and the application could like proactively explain you can do this, but you can't do this. I'm suggesting like this alternative solution and so on. So here's just some brief example of how interaction with this application could look like. So basically, some person is missing on the hill. So the user says, "Okay, I would like to search for this person. He's somewhere on the hill." So ground station asks like which side of the hill you would like to search. So you will specify like this side, and then the user says that he would like to also like search about the city, and the ground station explains that it's not possible to do this because it would be against the law, and then also ground station can suggest like based on the current situation that it will use thermal cameras for searching for the person and so on, and basically plan the mission automatically, show the mission and UI to the user, and the user says, okay, this looks good, and then just like hits play, and the ground station will do the rest. So this is one of the examples of like where you think language models could be useful. Other example is like basically about scalability to swarms. So if you want to control swarms, it's you have like few options. One is biologically inspired, that you define some distributed rules, and you set them to drones, and then drones behave autonomously. The other one is that you will centrally divide the task into subtasks, and then plan mission for each of the drones in somehow predefined way. Often this can be complex, mostly on the user side. So we are thinking about like this kind of application where the user defines just a high-level goal, and you would like to, I don't know, scan some specific area, and then distribute drones somehow uniformly across this area. So the ground station would basically try to parse this command, and then it would know how to like set up all these small missions for the drones so that it fulfills the task. So basically, this will be about managing the complexity of controlling the drone swarm into some simple language-based commands. Other potential application of language models in ground control stations or when controlling the drones is like managing the complexity of UI. So I briefly mentioned this. So idea would be that you want to define some mission and you don't want to like deal with the whole UI, but basically the idea would be to have software which will predict what you would like to do, like either before the planning the mission or during execution of the mission, and it would basically dynamically change the UI based on your preferences. So it would not show you like everything you could do in any potential situation, but it would somehow adapt the UI for your needs, so that you don't have to deal with all details and with like too complex UI. So going from something like which is on the top, some autopilot ground station, towards something which is on the bottom, that you will just like specify by a few clicks what you want to do, and the language model would configure the UI for your needs in a given situation. The other idea we had is about complex data visualization. Basically, we were talking with some people from universities and from customers, and usually the problem is that you have some complex robotic system, sometimes running in the robotic operating system, for example, which is like very capable. It can like collect lots of different types of data, and it can show it to you. But like usually, like this is very hard to deploy to the customers, because it is usually hard to make it work on specific Linux machine, which is running some specific distribution of Linux and so on. And it's very hard to make it work on other computers by people who are skilled at this. So what we would like to do here is to use language models to basically control the capability of the API of this robotic system, so that it's able to like tell you what is the data it is available for you. They will be also able to basically fuse the data into something which is like easier to understand and present it to you in a understandable way, so to the customers. So basically you would ask for some pictures, for instance. It would give you pictures and it would tell you, okay, I have also 3D model, do you want to see it? And if yes, then you can ask, okay, do you have some more detailed data? And it would basically show you in some easy web browser based interface that like it has also these data. So you would not have to know everything about underlying like implementation of the system. So this would be one thing. And maybe the other idea would be to use language models not for communicating between ground station and the user, but more like use it for the communication between the drones. So suppose you have some ground station, you deploy some high-level instructions to the individual drones in a swarm, and then language models would be used to communicate like different information between the drones. So the drones could like negotiate which subtasks they will be solving, or basically like share some information they found. Actually, AI game some time ago had like very nice example about this, that you specify some complicated tasks, and basically each individual in the game would negotiate with other individuals, like who does which part of the task, and then they would together as a collective fulfill this high-level task. So this is like also one idea where to use language models in the context of drones. And I think these are just some initial ideas we had, and like we will be happy to discuss other potential use cases in this. So I think that's all from us or from me. So thank you for the attention.
Thank you very much. Very interesting, and also very different topics that you cover here. So are you having questions? Anybody online? We have about almost 50 people online. A few here. Questions? Anybody online?
I would have one question, Oliver.
Yeah. Günther, I guess.
Yeah. Yeah. Thanks for the very interesting talk. So I'm doing games research, games analytics. I'm naturally interested in the first topic which has been presented. So I think that question goes into the direction of Jan. As I understand, it's basically everything is not scripted, which is very nice. And as you have shown in the example with the cook, so it also like gives rise to like emergent behavior, and which I think also like relates to replayability. But on the other hand, you know, game developers are also like sometimes very specific and are designing for a certain player experience. So the question probably is, how do you basically play test the different like emergent behaviors which could be exhibited by the agent?
Okay, thanks for the question. So yes, so of course, just like with anything open-ended or emergent, it's quite difficult to plan for it. But one thing that we test for is the kind of goal oriented decision making, right? So we have a lot of scenarios, a lot of situations in which we make sure that the agents actually do what they're told, at least to some degree. And then we test it also using the different background stories of the characters, and we can see that their decision making is different because some of them essentially, yeah, how would I say, because their personalities, the backgrounds are different, and their plans are likely to be different. Whether it's more aggressive, just like you saw in one of the videos, or they don't want to listen to you if you actually talk to them, if they're not convinced that actually you're their friend. And so for this reason, we have tests for standard kind of agential decision making for achieving certain goals, and then also how those solutions towards those goals differ when you have those biographies that differ. So that's one way. Of course, we do a lot of playtesting. So we actually try to set up the scenes in such a way that, you know, things can somehow emerge. We're not really kind of done with that yet. But in some way, there is no more better way to test it than making sure that the foundations are as solid as possible, and then providing a space that is combinatorial in the space of possible actions and combinations of those actions. So if you provide the world with sufficient objects and tools that can achieve different outcomes by different means, then you're essentially giving it the space to choose this, and then we can test if, you know, the solutions to those problems are different. And there's this really nice definition of intelligence by somebody called Michael Levin, and I don't remember exactly the definition, but it's something along the lines of that intelligence is different means of achieving a certain goal, and it kind of doesn't really matter how you achieve it as long as you achieve it, and the finding different paths or kind of routes in various settings or various scenarios is what actually makes you intelligent, by being able to adapt and have this kind of invariance with respect to the method of how to get to the goal. So allowing it here and looking at the end goal and the fact that it's achievable by different means should allow for this emerging complexity. And maybe let me just quickly share. I don't know if you can stop sharing. I'll show you another very brief video of this. And can you see the slides?
Yeah.
Yeah, there's another situation. I hope it works. It's not really so much emergent, but I mean, it's emergent in the sense that that I, as a player, try to actually get this character to do something, and because his background is one of Zeus, he's actually very arrogant and has kind of strong opinions about himself. And what actually happens, he keeps on being inquisitive, and he doesn't want to do the task. And apologies if there's some, I think there may be some bad words. But essentially what happens is that if you keep on talking, you'll see that he has this kind of personality that it makes it very difficult. Yeah, so even his reasoning and animations are somehow influenced by this. And it's actually very difficult to make him do things that you want, especially if they're somehow bad, because the language models are heavily kind of fine-tuned to be good. And yeah, so you can see there is, even though it's not decision-making, but yeah, so I'll stop sharing there. But essentially, you can communicate in many different ways, and just because the background is different, decision-making is different, and you will have totally different characteristics that in some sense reflect the collective knowledge that is actually learned by those foundation models. And what we do is, by priming it in a certain way, we kind of tap into different personalities, different behaviors, and that reflects not only in the conversation, but in certain ways also in the decision making. And it's just making sure that it's sufficiently visible to the player, that it's observable, that it's sufficiently different to make it interesting.
All right.
Question by way. Or Günther, are you finished?
Yeah, thank you. I just wanted to say, I think it would also be very interesting to run a user study and see if like the differences in behavior lead to consistent user experience.
Mm-hmm.
But I'm passing on to the other people. Thanks very much.
Thanks as well. Thanks.
Wait.
Oh, hi. Hello. Hi. Thanks for the nice talk. I also have a question for John regarding the large language model. So I think I remember that you mentioned you have been using GPT 3.5 for all the examples that you showed. And have you also tried any open source large language model which are also available for commercial usage, where you can like do this, for example, parameter efficient fine tuning for instructional tuning? Have you tried that? Or is there a reason to use GPT 3.5?
So the main reason for using GPT models is simplicity and the fact that they actually work. And if you use GPT-4, it would be best because the responses, the reasoning, and the way that GPT-4 works is just it listens to the instructions much better. So even if you have a lot of context, a lot of input into the language model, it is able to pick up many different instructions. Whereas with 3.5, it's actually much harder. But the cost is something that makes us use 3.5. And if it works with 3.5, it works with version 4. And in terms of the custom open source models, we continue investigating this. And the problem is that it seems that those open source models, they are good at certain things, but the things that the GPT models, especially 4, are really good at are the reasoning part, at least, you know, the things that are able to generate the plans that we want. And that is much harder to kind of elicit in the open source models. So for conversations, for some simpler things, the open source models might be interesting, but in order to use them for the decision making, it would have to involve some kind of fine tuning, whether through the parameter efficient methods or some other things. And we have already done some preliminary experiments on one of the models, and we are able to extract some plans that kind of seem to make somewhat of sense, but they're not as good as GPT-4. But we believe and hope that it's just a matter of maybe a few months until we are able to have a pipeline or a model that will be able to help us with this. But in that case, we might have to combine multiple models, one for conversation, one for decision making, because fine-tuning them for the specific task might be necessary. So yeah, so we are actively working on this, and it's really important because right now we have to pay OpenAI for all the tokens, but eventually we want to have our own models that will fit on consumer level PCs, on which they could then could have their own model.
You mentioned you want to extend this to multi-model to the multi-model setup. Does this also involve visual perception, like as a but the application will still be this game, like this game with a
so this game is essentially our focus now, because our sister company is a game development studio, so we have a lot of experience with building games. But the methods that we're developing in the game are kind of transferable to many different kind of robotics scenarios. So it could be used for general simulation, for essentially anywhere where you want to have some kind of agents. Of course, the actual execution of the agent going from point A to point B in the game is easy, because you essentially have those, path planning and so on. And in real robotics, you would have to deal with it somewhat differently. But it's universal.
I find it interesting, because I personally work with vision language models and also multimodal or large language models. So I assume if you extend this to to vision and large language model, you would probably need some visual encoder which is pre-trained on synthetic data, because your game thing is or about synthetic data has the large domain gap to a VIT pre-trained on ImageNet or other realistic data sets. And also I do not know much about embodied agents. So you have one example that showed you give this task of retrieving an X, and which is surrounded by a wooden fence. And I have the feeling that this character almost immediately knows that this X is surrounded by fence, and this is an impossible task to complete. Do you have a lot of prompts to describe this in the background environments, and what are possible, what's not possible, and what tools you have to do?
So I'm not sure if I got everything from the question, because it was a little bit interrupted, but in terms of what happens there is that the agent receives observations, which are textual descriptions of the world, and it creates a plan. And when the plan is not executable by the game engine, the game engine generates a signal that essentially describes what happens. So when he tries to pick up, it was actually this medicate. When it tries to pick up the medicate, the game says this object is unreachable. This is fed back into the language model, and based on that, the language model knows that it is not possible to reach that object, and because it has information about the proximity of the objects around, because we use a special way of describing the spatial information, it is able to reason that the medicate is next to a fence, and therefore the fence is most likely the thing that blocks it. So if you want to unblock the path towards the medicine, you need to use some tool. And because the language has all this information about wood, X, and X is one of the objects that it has all its observations, it actually combines those two things together. But also does it with a gun. You can actually shoot it, it can burn it, and it depends on the situation and on the prompting and on the personality.
Thank you so much.
Thanks.
Anybody else with a question? So I have a couple of technical questions, but I will do that over email. I think that nobody else cares technical stuff related to the drones. So I will send you an email. If there's anybody else with a question, with a general question on the presentation today?
Yes.
Yeah, Moritz?
For Mrs. Afanasjeva, the surveillance drones in South Africa, are they used right now in a scale that is relevant? Or is this more like a scientific approach with
So if I heard correctly, you're asking if it's already available, like if you already make it available, or if it's research, right?
Yeah. Yes.
Yes. So basically, we are in discussion with several potential clients. So we don't have a client yet, but so our drones are not flying at somebody else's property yet in South Africa. But that's the goal, like to basically to do it as soon as possible, because we want to get real feedback for our work, research and development. So it's like applied research from the beginning. Yeah, so I think that's probably answers your question, or maybe if you'd like me to elaborate on anything more.
Yeah, yes, that answers. Thank you. But another question, like, are there any concerns about more populated areas? I mean, the use case with the poachers is very clear, but like, does it make people nervous if drones are flying around for surveillance?
Okay. I think that depends a lot. So, for example, a good example is that that use case. It's our friends from this community crime prevention organization. So they are very technically oriented. So the thing is, in Europe, you have obviously. I think in South Africa it also depends. You know, a particular situation, but in Europe, people are very concerned about privacy, flying camera, this and that. When your concern is that you don't want your house to be invaded and you don't want to get tied up and hurt and mugged or you know, intercepted on a street with a knife at your throat, so you look differently at basically added value that the technology can bring to you. I think that also is why, as I mentioned, like for us, looking at this type of use case is so rewarding, because we believe that people will. Like if it works well, it will actually improve lives and save lives, and people will use it if it helps them, right? So, for example, with these community crime prevention guys, we've been discussing exactly that, and they were saying, well, you know, they communicate with their community all the time. It's a few thousand users of that application in that local area. And they broadcast if there's a fire, if there's a riot, if there's any kind of municipal alert, like the water isn't running in that street, everything is reported immediately. And people are there's a lot of kind of trust built in that community and transparency. So they were saying that they think that if they communicate, okay, drone is another flying camera. It's not like there's surveillance on top of your head all the time. But it can help us get, it can help us respond to some incidents faster, prevent more incidents from happening, etc. Because it's also a deterrent, right? If you're a burglar and you know that there's drones flying around, you probably like will reconsider. So they think that this would be accepted much better, or like positively, because they already have thousands of cameras that they monitor. So people are used to that. And yeah, and they're also a professional organization. So obviously they're not going to abuse the data or sell it off to someone, etc. So also that I guess depends on who is running the operations and what's the relationship with the community there. Obviously, if you give it to the police, or like, I mean, nobody's going to ask them, and you know, or like they're not going to ask anybody, and will not probably care much. They're going to just do their job. But with this non-profit organization for crime prevention, that's the case. Yeah, it's a lot about the communication and trust in the community, and it's actually it's like super nice use case, very inspiring, because it's literally, this organization was started by the locals from that town. A few people, they still have maybe like a dozen people in total working there, but they're super professional. They have this control room with monitors with all different alerts that they receive. They built that app that connects everybody. They're more efficient than any other, anyone else you could. They're like 911 for the area. Like for example, if you get in a car accident nearby, you don't call the police, you don't call medics, you call CCP, Community Crime Prevention, and they make sure that somebody gets to you, and you don't end up waiting 2 days for the police to arrive, or many hours for medics to arrive. So yeah, that I hope also answers your question.
Yes, thanks.
Welcome.
Okay, I think time is up. We need to clean the room here at least. Thank you very much for this very exciting talk. And I'm pretty sure if anybody has some remaining questions, you can send them to me. I will forward them, and I will contact you by email with my questions then.
Wonderful, Oliver. Thank you. And thanks everyone for coming. It's actually very cool. So many people joined, and yeah, we're very honored.
Thanks a lot, everybody.
Thank you very much.
Thank you. Bye-bye.
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 Bye.